Guys, this might be a little bit complicated to see. I'm not sure. Hopefully it works out though. I'll go ahead and apologize for my coughing. But we have Algebra 2, Module 3, Lesson 20. And we're talking about transformations with graphs of logarithms and exponential functions here. And so let's take a look at it right quick. It says sketch the graphs of the three functions f of x, g of x, and h of x. And now for I, it says describe the sequence of transformations that takes place of f of x. So f of x is being our parent function. Okay, f of x is our parent function. And we're going to g of x. Well, let me just graph it for you over here on Desmos right quick. There is the parent function. There is the g of x function. So right now it's easy to say that we've had a translation of 1 up, right? Let me see if I can get this to do correctly. And maybe it's not. Okay. So we'll translate up 1. Okay. I wrote that all the way to the right because you normally do your translation and stuff second. But that one's easy. We can see how that goes up from 0 being the vertex 0, 0 to the vertex of being 0, 1. So easy translation up 1. Now, we can also tell that it's not necessarily the exact same size of a parabola. It's a little bit skinnier. So there's been a horizontal scaling, or we would refer to that as a vertical stretch. We've stretched it. We made it skinnier. But what kind? Well, it's going to be a half. So let's call it a horizontal scaling. I'm just going to call it an HS of equal to 1/2. Okay, and I'll probably start writing this as a translation equal to 1 plus being a 1 up or 1 down. Or I might write plus 1 or minus 1, knowing that that's a translation up or down. But why is it a 1/2 translation? Well, if you look at this, I'm sorry, a 1/2 horizontal. If you look at the x here, okay, at 1/2, it's at 2, okay? And if we were to bring that straight down 1, that would be at 1/2 1, right? If we were to bring this straight down to here, that would be a 1/2 1. Well, here it is a 1, 1. So your y value is the same, but your x value is half of what it would be, or what the original was. Okay, so since it is half, because if we were to bring this back down, if it was not translated up 1, okay, brought this down to a 1/2 1, then it is half of the original. And that's why that is a half horizontal translation. Okay, or transformation. All right, now 2 here, I wants us to look at 4x squared plus 1, or h of x. So let's do away with that. And let's look at 4x squared plus 1. Now, that one looks a lot like the last one. So how do we want to talk about it? Okay. Describe the sequence. Well, we can see it really quick that there is a translation of 1 up, right? Going up 1. Now, there is a horizontal stretching, or horizontal scaling, or vertical stretching is what's happening here. But it could also be considered a horizontal shrinking. Okay, there's a lot of different ways we can talk about these. But what's happening is we have a vertical scaling here of 4. Okay, and the reason why we call it a vertical scaling is because it's not in the parentheses. It's on the outside of the parentheses. Here it was inside the parentheses. So that has to do with the ets, right? If it's inside of it. Here it's kind of like it's outside of it. It's still affecting it, and it's the exact same thing. Okay. It's still, I can show you that it's the exact same graph right here. If I get rid of the red and look at the green and look at the blue, they coincide with each other. Okay, they're the exact same graph. Okay, but here we want to talk about it as a vertical scaling. So we would write it as a VS of 4. Okay. Now, how can we justify saying that? Okay, let's get our parent function here. Okay, and if we were to shift it down to exactly the same, okay, here at 1, we're at 1, 5, right? Here we're at 1, 1. But remember, this is shifted up 1. So if we were to shift that down 1, that y becomes a 4. We're at 1, 4. Okay, so that's the reason why we have also a vertical scaling of 4. It's that same thing. A vertical scaling of 4 and a horizontal scaling of 1/2 is the exact same thing. And I showed you that here. It's going to be the exact same graph. Okay. All right, so it says explain why g and h are equivalent functions. Well, the best way to explain that they're equivalent functions, I guess, would be to just do it. Okay, let's just do it here. G of x is equal to 2x squared plus 1. H of x is equal to 4x squared. There's no parentheses there, right? Well, if we were to do the parentheses, that would equal 4x squared plus 1. So it's the exact same. And that's why. There's no difference here and here. Okay. All right. B says describe the sequence of transformation that takes g of x of f, okay, or f of x is equal to sine of x, and then g of x is equal to the sine 2x minus 1. Well, if we look at that, hopefully you can tell me right off the bat that there's going to be a horizontal scaling because there's something being done to your x, and then there's also a translation. And since this one's easy, we're going to call that a translation of, it's probably not good to do that. Well, that's fine. T. I'll try and make that a better T, where it's a capitalized T. Okay, T is equal to, and here we're going down, so it's going to be 3 negative, or 3 down. However you want to write that in there. 3 down, 3 negative. I just try and make it easy because this is not the easiest way to write. Okay. So now we've got that took care of. Now, what is that 2? Well, the 2 is the same thing as our original g of x right here. And we talked about that as a horizontal scaling equal to 1/2. Okay. So that's all you'll need to do. A factor of 1/2 down 3. All right. Now let's see if I can find C here. All right. C says, describe the sequence of the translation of f of x as sine of x. And then we have a h of x as 4 sine x minus 3. All right. Now, let's just think about, well, let's just go ahead and get this out of the way. This is the same thing, right? Translation 3 down. Okay. 3 down. Now, if you will think about what's going on just right here. Okay? Think about it. That's saying for all of your x, whatever your x is, to get your y here, you're going to multiply it by 4. Okay? So whatever x is, we're going to take that and we're going to multiply it by 4. So the easiest way to call that would be, I would call that a vertical, oops, let me erase this. I'm just going to call that a vertical scaling of a factor of 4. Okay, so if you have a 1x, you're going to multiply that by 4, and now you're going to have a y of 4. So you're going to have 1, 4, and you're going to stretch that up. Now, you don't technically, because you're going to have to subtract it by 3, but we don't really care about that whenever we're talking about the translation and the transformation right now. We're just trying to figure out our vertical scaling and horizontal scaling is what I'm trying to do for you right now. Okay. So D says explain why G and H from part B and C are not equivalent. Okay. Well, they're not going to be the same expressions, even though the other one was. Okay. If we go back to B here, B is simply 2x. It's not 2x squared, right? These are not equal. Oh, let's see here. Yeah, because we had 2x minus 3, and now we have 4 sine of x minus 3. Well, we know that those are not going to equal each other, okay? So they're not the same graph. They're not going to be even the same function. So let me see if I don't think I did that over here. No, I did not. Yeah, okay. So they're not the same function. Not same function. They're not equivalent. And that writing is awful on this, but sorry. All right. So it says sketch the graph f of x by identifying and plotting at least 5 key points to the graph. Okay. Well, I've did that over here. So let's graph it right quick. If we look at it, there's us 5 points. So 1 is 0. 2 is 1. 4 is 2. 8 is 3. Now, let's think about it. To what power of 2 would I get a negative 2? I'm sorry. To what power of 2 would I get a negative 2? Yes. Well, that's going to be a 1/4. Okay. So, at negative, or at 1/4, I'm going to have a negative 2. So something like that. And then at 1/2, I have a negative 1. Something like that. And then at 0, or at 1, I have 0. 1, I have 0. And then at, oh, that's not 1. Sorry. Got off a little bit. Oh, that's really hard to draw. Those were not really good marks there. And then at 2, I have 1. and at 4 I have 2, and at 8 I have 3. Okay. But y'all see it over there, drawn. It's going to look something like that, though. So if I plug in a 1 here, I've got to get a 0 for my answer. So to what power of 2 is 1? Well, that's 0. To what power of 2 is 2? Well, to what power of 2 is 2? Well, it wants to scroll up like that, sorry. What power of 2 is 2? Well, that is 1. What power of 2 is 1? Well, that is 0. Anything to the power of 0 is 1. So just little logs. That's going to get on my nerves. Sorry about that. Okay. All right, let's go on to the next one. I'll try not to graph those anymore. I'll just let Desmos do it for you. All right, describe the sequence transformation that takes place from F to the graph of g of x. Okay, so what's happening here? The only thing would be that we don't have any type of translation. And it's not going up or down. But we have this 8. Okay. Now, it is inside the parentheses. Okay. So, anytime you see it inside the parentheses there, I want you to call it a horizontal scaling. Okay. Now, remember when it was a 2 inside the parentheses, it was a 1/2. So here, it would be a 1/8. Okay. This log base 2 does not matter for that. Okay, don't start saying, well, it's actually going to be a 3, blah, 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 blah. Don't worry about all that type of stuff. Okay, it's still a horizontal scaling with a factor of 1/8. Okay. Now we're doing the same thing. We're talking about transformation from F, which is just our regular log base 2, to a h of x, which is 3 plus log base 2 of x. Well, that's going to have us as a what? That's still going to be even though it's at the front, it is a translation of 3 plus, or up, 3 up. Okay, we're still going up by 3. Vertical translation, 3 units up. Now, it's going to want you to graph these and notice the patterns. Okay, well, it just wants you to write these in. Okay. So F was just our original log base 2, right? Log base 2. G of x was log base 2 of 8x. And then this is 3 plus log base 2 of x. I guess I need to put that there. Of x. Excuse me, guys. Now, we're going to want to do this. So, to what base of 2? We've already got these. I'm going to go ahead and write these in over here. They're on our graph already there on Desmos. 0, 1. Sorry. Something about that spot that it goes to every time. I don't know why. And 2, 1. That would be 2. And that would be 3. Okay. Now, what happens whenever we multiply all of these basically by 1/8. Remember? It's a simple scaling of 1/8. So what happens when we do that? And it's a little bit tricky. Okay. So let me graph those over here for you. Here's our original graph. Now, here's our x to the 8th, or 8x graphed. Okay. So what's happening here? This is a horizontal scaling. Okay. And it's by 1/8. Okay. So if we were to look at 1/4, we would get a 1 for the g of x. And for the half, it's at 2. And I'm just plotting this points. And then I need to scroll out a little bit there. And at 0, I'm sorry, at 1, we have, what was that, 3? 2 is at 4. 4 is at 5. And 8 is at 6. Okay. Now I want to get rid of this purple here and scroll down for it. And now I've just got this translation up 3. Well, what's happened? Still have the same thing. So horizontal scaling of 1/8 or a vertical translation up 3 are giving me all the same answers. How is that? Hopefully you're catching on to what's going on here. Okay. Now that we have graphed that, we should have done that. Oh, now it wants us to graph all 3 on the same axis. Well, let's just look at that over here. I'll put this one back up. And we can't see it because it's the exact same thing. All right. So let me go ahead and take those off. Now you know that 8x and vertical translation up 3 is the same thing. And let's see what else it wanted to know. What did it say? And notice any pattern. Okay. Now here, let's use a property of logarithms to show that g and h, we've already showed that g and h are the same. Well, why is that? Why are they the same thing? Think about it. Let's go back to our, sorry guys, trying to think of what our g of x was. 8x, g of x is equal to log base 2 8x. hx is equal to 3 plus log 2x. Now, if you look at that, we can break that apart, right? We break this g of x apart. Let's break this g of x apart and say log base 2 8 plus log base 2 of x. Well, to what power of 2 is 8? That is 3. So here we would have, let me bring down here, that would be 3 plus log 2 of x, which is exactly what we have right there. So if you break apart that log, you can end up getting that exact same function. And that's the reason why you're getting the exact same graphs and the exact same points. Okay. Now, G says describe the graph of P of x of log base 2 of x divided by 4 and of log 2x and justify your answer. Well, what's happening here? If we were to break this apart, we'd have log base 2 of x minus log base 2 of 4. Well, log to what power of 2 is 4? So that would be a log base 2 of x minus 2. So that is a translation down 2. So that would equal a t of 2 down. All right, describe the graph of h of x plus 2 as a horizontal translation, or horizontal scaling of the original log of 2. Okay, so here we're talking about it as a translation up, right? So now we got to take this and put it back the other way, because this looks like a translation, but it wants us to talk about it as a horizontal scaling. Okay. Now remember, that's the same thing as log 2 of 8, excuse me, plus log 2 of x. And since those are this, we can rewrite that all as log 2 of 8x. Now we can talk about it as a horizontal scaling because it's inside our parentheses, basically, multiplied by our x. Okay. So that's the reason why we can now talk about it as a horizontal scaling. Okay, so it says do the functions right here. H of x is equal to log 2 of 8 plus log 2 of x, and k of x. Okay, do they have the same graph? Well, no, those are not going to have the same graphs. Because you can plug in any number until that's not going to work. Let's plug in let's do log base 2, so let's just do 2. 2 will work. So we'll have log 2 of 8 plus log 2 of 2. So that's going to be 3 plus, oh, I did that. 3 plus 1 is equal to 4. Okay. Well, if we do log 2 plus 8 here, so what? To what power of 2 do you get 10? Well, that is not 4. Those are not equal. That will not equal that. 2 to the 4th power is not equal to 10. So therefore, you can tell that that is not going to be a correct same graph. Okay. Let's do a couple more. J says use the properties of the exponents to explain why the f of x is equal to 4 to the x power and g of x is equal to 2 to the 2 power are identical. Oh, well, that's simple. If you have, f of x is going to stay the same, right? 4x is going to stay the same. There's nothing we can do with that. But g of x, if you raise that's 2 squared and then 2 to the x power. So you can always say, if you were to break that apart and say 2 squared to the x power, so that is an exponent raised to an exponent, so that's just multiplying, right? So then you're going to have 4 to the x. And those are the same. So that's the reason why those are identical. All right, let's see what K has for us. And we have says use the properties of exponents to predict what the graphs of g of x and h of x look like compared to one another. Describe the graphs of g and h as transformations of the graph of x, f of x of 2 to the x. Okay, so first of all, let's just talk about those as, let's just describe them. Well, here we're going to have a g of x is actually we're going to have to rewrite this. We got a base of 2. Okay, that is our original function. So I'm just going to rewrite these. I don't know if I've graphed these or not. Maybe I did here. Okay, yeah, maybe it looks like I did. So I can graph them after I show it to you here. So if I do g of x as equal to bases of 2, so that would be 2 squared times 2x, 2 to the x, right? 2 squared is 4. So now I've got 2 squared times 2 to the x, which can just be rewritten as 2x plus 2. Same base, we multiply. If we have the same base, we add the exponents, right? So g of x is now equal to this. So let's look at h of x. H of x, well, that's the same thing. So those are going to be the exact same thing. All right, let me see how I graph this for you. Let's see if I There's a base 2. Let's see what's going on here. Oh, I think I just deleted that one. Oh no. Let's go undo. Okay. There's g of x. Well, can't quite make that big enough. There we go. There's x plus 2. And then, oh, there's the 4. But it's not going to do anything because it's the exact same points. See there? I just don't have that one in the... I just got that one as dots instead of a line. Yeah, that's the reason why they're the exact same. If we use our exponent rules, log rules, whatever you want to call it, you're going to have the exact same g of x and h of x there. Okay. And let's call it quits for the day, and I'll work on the next one for tomorrow. We can do this one. Let's do I right quick. It's not going to take long to do I. Sorry. Got your hopes up. All right, so what's going to be happening here? What's the difference from f of x and g of x here? Well, we got a negative exponent, right? So what's going to happen with a negative exponent? It's going to reflect across the y-axis. Okay, it's going to reflect across the vertical axis here. So let me draw that for you. Or not draw it, but let me graph it here for you. See how that is just a reflection across the x-axis. All right, now let's look at h. What is h? Are those going to be the... Well, that's the same. Yeah, so if we do h, if we get that to a base of 2, okay, so, excuse me, how do we get that to have a base of 2? Well, that's going to be 2 to the negative x. That puts our 2 in the denominator, right? So let's see here. Did I do that? Looks like I did, maybe. Maybe not. Oh, yeah, I did. Yeah, see the black's going to be the exact same thing. It just moves it to the... So if you can use your logs and exponent rules to explain these, then you don't have to graph more than 2 of these, right? Because it seems to be that these are all working out to be the exact same. That's the reason why I had y'all do a review on those log properties and exponent properties, and then the video on transformations. So, all right, that'll be it for today, and I'll work on the rest of it for tomorrow. Just leave your assignment open in assessments, and you can finish it tomorrow.